We're ready to get started. So welcome to Union Session U21D, a new generation of scientists. Today's session will be devoted to a discussion panel with the 5 James B. Macelwane Medalists from 2019, and will be co-chaired with Stephen Davis from UC Irvine, who was a 2018 medalist, and myself. I served as a member of the Macelwane Committee for 5 years and actually chaired it over the last 5 years. So I've had the good fortune of seeing about 220 nominations over the past 5 years. The Macelwane is given annually to 3 to 5 honorees for outstanding contributions to the geophysical sciences by an early career scientist within 10 years of obtaining his or her PhD. Medalists are actually conferred as AGU fellows at the time of the award. It's probably one of the most competitive AGU awards in my mind. For example, we had 63 nominations this past summer and 5 medalists. And this is across 15 different sections of AGU. And so it is, in fact, the creme de la creme. They're very accomplished scientists. And so we want to actually honor them and give them a hand of applause. Today's panel discussion will be focused on the medalist's own journey and experiences with early career successes and failures. And I think you'll hear from a number of them talk pretty openly about failures. Not everything works, even for people who are this incredibly successful. So we'll start with each panelist making about 5 minutes of introductory comments and observations that will stimulate later discussion with the audience here. And it's being recorded for viewing on AGU Go later, but it's not being live streamed, so we won't have questions from an online audience. In the second half of the session, my co-chair Stephen and I will moderate the panel discussion with the audience, and then Stephen will provide some concluding remarks. So once we're into the discussion part, when the panelists actually occupy the table here, we want you to be fully engaged in asking questions of the medalist, particularly after their introductory comments. So let's go ahead and start with Amir. Stephen, you want to move this on to the Mac? Here. Yep. No, go ahead and get it.
Good morning, everyone. I'm thrilled to be here today. So I was asked to say a few words about my research and a little bit about my career path and approach to research. So I'll try to do that in the next 5 minutes or so. Broadly, I work on different types of hazards, and these days, more specifically, how different hazards interact with each other. For example, how one extreme event can trigger another extreme event, or cascading hazards, rain over burned area, or compound ocean and terrestrial flooding, droughts and heat waves, the interactions, the physical drivers, and how they can exacerbate each other. So this is also known as compound hazard or compound extreme. There are long list of different types of compound hazards and events that interact with each other. So that's one of my main areas of research, but there are some other areas that I work on. As an example, in a coastal system, you can get flooded by the ocean alone, or by riverine flooding or terrestrial flooding, or both at the same time. So we are interested in the interactions between coastal flooding, ocean flooding, and terrestrial flooding, especially considering sea level rise. as sea levels are rising, the chance of flooding and flood impacts in coastal areas increases, obviously, because one of your drivers is changing. Slowly but surely, that will change your flood risk. But our current guidelines treat these different drivers separately. So we have flood frequency maps that are mainly based on one driver. NOAA has ocean water level analysis framework that's again based on one driver. But the question is how they interact with each other, how they change the risk when you consider multiple drivers. And that means in coastal areas, in estuary systems, how your flood risk will change. And this is not just about sea level rise and terrestrial flooding, but also it's related to human development, whether there is a boundary or not, whether artificial or man-made boundary like a city. It makes a huge difference. So we look into evolution of systems like this, coastal systems under different future sea level rise and future flooding scenarios. Another example would be looking into response of snow melt and snow water equivalent under different levels of warming, potential impacts on flooding, water availability for agriculture, and so forth. Again, it's another example of different type of drivers contributing to, in this case, water availability or potentially flooding, early flooding, spring flooding in snow-dominated regions. So another example is drought and heat waves and impact on agricultural production. So these are the type of hazards that my group works on. About my career path, when I was a freshman undergrad, I was 100% sure that I wanted to get into construction engineering. I knew that. I was 100% determined. But in my sophomore year, I did an undergraduate research with a glaciologist, Fariborz Vaziri. And honestly, when I started that, I didn't really care about the actual job. It was just like some extra money, right, for an undergraduate student, research experience. So, but slowly, I got more and more interested in the topic. One thing led to another, and my career path changed completely. So that's how I transitioned from someone interested in kind of construction to like hydrology. Okay, so I was asked to say a few words about my approach to research. I wanted to introduce this amazing book, Letters to a Young Scientist by biologist Ed Wilson. And this book influenced me a lot, so I thought I'd share a few sentences and paragraphs from this book, and I will link it back to my work. So in this book, Wilson outlines a bunch of principles, principle number 1, 2, and one of them is march away from the sound of the guns. And by that he means if you see a topic is super popular and everyone is talking about it, stay away from it, okay? And basically his idea is that you need to focus on thinly populated areas and fields, then you can quickly become authority. I thought about this a lot, and I encourage everyone to think about this too. It makes a huge difference. Like in the case of compound events I mentioned, the methods we use are already out there. They have been out there for a long time. But in 2013, if you look at the literature in 2013 about this topic, you see very few papers. Now you see probably around 100 papers a year. But when we started, it was not a popular topic for sure. So again, the methods was there, but we tried to come up with questions that were at least unique at the time. So there are some more, so I'm just giving one example. I don't have much time, so this is just one of them. But I encourage you to read this. There are some more interesting principles that I'm sure you will enjoy. The other one is he categorizes research into broadly 2 different areas. So in one general category is you have a specific research question and you're looking for a solution, right? And of course, if the question is really important, the impact will probably be bigger and more. But and basically he describes this as a hunter who looks for a specific query, right? But he talks about a different type of approach where the search is not for solution to a problem, but the search is for questions that are worth solving. So in this second category, basically you're searching for unknown phenomena or patterns of known phenomena, like a hunter open to anything interesting. And this may sound a little weird, but again, I've thought about this a lot, and I think if you think about this very deeply, you will find very interesting ideas and ideas to pursue. And I really encourage you to think about this in future. So this is my research group that I'm very proud of. Some of them are here, and some of them are not in this photo, but thank you very much.
Thank you, Amir. Anton Artemev? Did I mispronounce your name, Anton?
It's fine.
It's fine.
I use different type of pronunciation. Yeah, I think.
Oh, sorry.
Should be. There are tools there, so it should be quick. Should be PC, I think. Okay, so I think I can start before slide. So there is good things to be second. At least I know how it should looking like, because it's not very clear what can be said here. Yeah, really, no slides. Should be. This is second. Oh, yeah, it's me. Yeah. No problem. Yeah. All right. So, I'm mostly working about the space plasma physics, and this is something which is happening quite far from the Earth and affecting us very indirectly. It's mostly important because increasing number of satellites on the orbit and all the hazards which space plasma and space weather brings to our electronics device on the orbit, and especially to our ground-based electronic systems closer to the polar region. So we would like to know, and we would like to know how the plasma around the Earth evolve. I mean, plasma is just ionized gas, so something which is moving fast and have a large temperature and described by Maxwell equations. And you can see that mostly what I'm working on, it's two regions in the space. It's mostly, the Earth size is correct, so you can see it's quite far from our planet. So the one region is a little bit closer to our planet, and mostly it's called radiation belt, so it's about how high energy particles, charged particles, and how energy plasma affect our operation of spacecraft, and how their dynamics change with the influence of solar activity and other processes around. And another region in space, it's a night side, Earth's magnetosphere. It's a second yellow box here, which is a little bit further from our planet. And this is mostly about the strong electric currents and how are they generated by charged particles. And you can see that, the places are quite separated in space, and they are, believe me, quite separated in the methods which we use to investigate them, especially speaking about the spacecraft we use to investigate the space. And there is one interesting detail allowing me to investigate both of them and spend some time, get some results for both of these regions. And this is the fact that the theory describes them in the same way. So we use the same equations to describe these different types of systems. And this is nice because equations have been derived many, many years ago. We believe in them, and it's almost everything what we believe in, because other things are like measurements have a lot of errors and uncertainties. So theory somehow join our investigation in all these areas around. Can I click next one? Yeah. And I just, before making this presentation, I just quickly look on the the most popular journal in our field of space science is JGR Space Physics Journal. And I take a look on publication starting from 65, I mean, from the beginning of space science era, when we start launching the spacecraft for investigations, our surrounding space, and up to this moment. And I just divide all the publications which I found there into 3 categories, and you can see how spacecraft observation is mostly observational and experimental part of our field. Red is theory, which is mostly theoretical things. And blue one is just something between of these two things. It's less like comparison and joint investigation, both from theoretical and observational point of view. And you can see how the publication rate evolves with the time. So we have less and less observations, we have less and less theory, so less and less separated investigations, and more investigations which join both this direction. So it seems like, at least in our field, the combination of theory and observations, combination of experiments and equations give you more chances to reach more or less significant results. So I think I will just stop here right now. So and of course I'm exactly in the blue one. So I'm doing something between the theory and simulations and observations. Thank you. Thank you.
I'm too old to do what Anton just did, jumping off the stage here. Thank you, Anton. Emily? This is Emily Fisher from Colorado State University.
Hi, everyone. Thanks for being here this morning. It's nice to see some friendly faces now that I get up from my seat. I don't have any slides today. I have a set of remarks, and I'll try to respond to some of the questions that were posed in an email that we got about this session. Actually, I'll tell you one thing about my science. I care very deeply about air quality. I'm not sure why, and I have since I was 5, I would say. It's working on air is a calling. So what do I work on? That was one of the first questions that were posed. How do you pick what to work on, and how do you pick what not to work on? So I thought through this, and this is what I would say. I like to work on things that I can see around me. And so examples of that are, in the Western US, there's a lot of oil and gas development right now, and people ask whether that impacts their air that they breathe. And so that's something that I work on. Wildfires. Wildfires are big things that affect a lot of people. That's something that I've decided to work on. Other things that I can see, there aren't always women at the table. That's something that I work on. We're not making the progress we need to make in diversity in our field as fast as we need to make it. We can see that. Everyone can see it. That's something we need to work on. So those are the kinds of things that I focus on. Things that I don't like working on are things where I feel like I could spend a lot of time and make a marginal improvement, or something that I've already failed at. Those are things that I just try to let go. Other things that I like to work on. Topics that can span local to global. So I love it when my research can have something very tangible. I work at the land-grant university in Colorado, and so I like to have an aspect that's local, and I like to have something that extends from local to global, because that's sort of the beauty of the earth sciences. We have a lot of choice if we pick that framing. I like problems that I'm not quite sure I know enough to work on. So boredom is my enemy, and so if it's this sort of little bit of mystery is something that will keep me engaged in something. I like to learn new things. And finally, I like to work on problems that require teams. So I really feed off other people's energy. And one thing I've realized is I love organizing people, and I love watching them work together, even if after the organization I just step back and watch. And so I find great joy in bringing people together, and I find that the process is longer when you work on teams, but the product is better, and that's worth it. So, all right, so the next question I think I was supposed to answer was mentoring, about mentoring. How do you pick mentors? Who has influenced you? Something along those lines. All right, so I think the key to mentoring is to have a network. So you need so many different kinds of support to be successful. You need people who will sponsor you. You need people who will provide honest feedback. You need people who you can be brutally honest with and who will be brutally honest with you. You need emotional support, and that requires a lot of people because we're not magic unicorn humans. So you can't possibly expect one person to provide all of that for you. And so I thought I would give some examples of some of the people and what the kinds of things they've taught me. So I would say Jack Dibb taught me how to think. I was a horrible, horrible writer when I started graduate school, and Bob Talbot was teaching me how to actually write by what must have been painfully editing 25 drafts of my first paper. But Jack Dibb sat me down and said, "What are you trying to say?" And I was like, "Oh, yeah, I should think through that. Thank you, Jack." Jenny Moody was the first woman to reach out to me and brought me down to the University of Virginia and spent 3 days with me, and I still reflect on that, and I'm not sure I've ever thanked her appropriately. Dan Jaffe, who was my PhD advisor, taught me it was okay to be excited, to be late for things, and I mean this in the very best way, to be super excited about whatever you're doing, that you're late and 100% into it, such that you might be late for the next thing, and that's okay. And when I'm late for something, I think I'm just like Dan, and that's fine. Dan's awesome. Daniel Jacob at Harvard, I would say, is the best manager I've ever seen, and I say that from the perspective of that he has built a culture of a collaborative scientific team where everyone's working together and everybody feeds their things back in. Dan Schrag at Harvard, Francis probably knows what courtyard I'm talking about, took me into a back courtyard at Harvard. It sounds sketchy when I say it that way, but right at the end of my postdoc, and said, "Emily, when you leave here, I want you to think about yourself as a scientist, not as an atmospheric scientist." And that, I didn't understand what that meant at that moment, but when I, over the last few years of being a faculty member, that has given me enormous freedom to take on different kinds of problems than ones that are only rooted in the atmospheric scientists. I learned a lot from serving on the ESWN Leadership Board. I think that's an excellent organization, but just watching how those women are leading and trying to follow in their footsteps. Frank Flocka taught me in the last year or two how to navigate the C-130, NSF NCAR C-130, and that was wonderful. And the members of my WECAN team have just been a wonderful set of colleagues and mentors. We're supposed to talk about failures. I missed my first field season as a PhD student. I did not build an instrument that worked. I could not detect peroxyacetyl nitrate, and I sat that one out. And it turns out I'm still here. I also broke the NCAR Pan-GC, and we leaked radiation all of our entire NCAR lab. And I've also had personal tragedies occur. And these things happen to everyone. All right, so key advice. You should take risks. You can figure it out, or you can find a team or hire someone that's better than you. So I think that the thing I'm most grateful for was that at CSU, when I asked if I should do something, people said, and Dave Randall, I can see him sitting in the back, said, "Do you think you can do it?" And I said, yeah. And he said, "You should do it," something to that effect. And I think I would have really regretted not taking those risks. I don't think as early career scientists you should be afraid of interdisciplinary work. So I think sometimes you can feel this pressure that as an early career scientist you really need to have depth, and that is true, but building interdisciplinary teams to work on real big problems requires a lot of time, so we have to start now. It takes years to make the friendships, learn the languages that need to be built in order to do really meaningful interdisciplinary work. In my own career, that is on the health side and working with social scientists. And the last thing I would say is that we should be stumbling up. And I just read a really great book called The Person You Mean to Be by Dolly Chu. So I am always thinking, how can I be a mentor? How can I contribute to equity? How am I part of the problem? Where are my blind spots? And I just accept that I'm a work in progress. That's that.
Thanks, Emily. That was elucidating. Francis McDonald, UC Santa Barbara. Okay,
I'm going to try to build off the style of Emily, and I don't have any slides and just some notes that I'll look at here. And what I'm going to do is I'm just going to start with a little bit of an introduction about what I do, but then I'm mostly going to give you sort of 5 talking points that are sort of like recommendations of things that have been important in my career. And those are going to be and they're going to be repetitive from some of what you've heard, but be bold. Be bold and stubborn and take risks. It's been important for me. Be cross-disciplinary. Don't be afraid to be cross-disciplinary, and this overlaps with taking risks. Try to be an excellent collaborator. Be the best collaborator you can. This is your community, and really investing in those collaborations and taking them seriously have been extremely important for me. The 4th point I'm gonna talk about is really asking for help. And part of that is being a good collaborator, is asking for help, but also just knowing you can't do everything and not being afraid to ask help when you need it. And the 5th thing I think is important that for me at least, that really speaks to failures is be honest with yourself about finding a release. Like, find whatever that release is, because things are going to suck sometimes. And when they suck, you have to be able to go for your release, forget about it, and then come back fresh again, because it's not going to be cheery all the time. Okay, so I'll try to get to each of those 5 points in 5 minutes. But to introduce a little bit about myself, my research combines field geology with analytical techniques, primarily isotope geochemistry and geochronology, to try to address and test what I think are important hypotheses in the way the world works, particularly how tectonics interacts with climate, surface processes, and life. And since my PhD, I focused primarily on this question of extreme climate change in the geological record, and focused on the timing and extent of these events called snowball Earth events, like how extreme and how how cold has our climate experienced, and what was the nature of the super greenhouse aftermaths. And during this work, I think we've demonstrated that twice the whole Earth was covered with ice. And so to do this, and this is in part of my first talking point of trying to be bold, early on, I took a risk in investing in geochronology, investing through the design of my lab, through the choice of field areas, through the choice of postdocs, as well. And this was a risk because I wasn't trained as a geochronologist. I probably didn't have the background to go into this the way I did, full head first. But I took the risk and decided this is important, that we've got a problem. If we really establish a timeline, this is the most important piece to test this idea of extreme climate change. And I think with a little bit of luck, really relying on excellent collaborators and postdocs and students, I think the risk has paid off to a degree. And so to the second point is be cross-disciplinary, and this builds off of something that Emily was talking about. This is a risk because to be cross-disciplinary, you have to invest the time in really reading about a literature, getting deep in a literature, and then when you have found this subfield that you're interested in, you've gotten deep in, you're going to bring to it the other skills that you've developed in your other field. You're going to bring a new perspective to it. And I think a lot of the advances that are happening right now in our fields are cross-disciplinary. So, for example, as I became more convinced of the fidelity of this record of neoproterozoic climate change, I wanted to get into causality, like why has this we experience these large changes in climate. And this has been difficult for a couple of reasons. One is, as my wife reminds me, causality is really hard. She works on randomized control trials, and so trying to get at causality is definitely not easy. But two, just in more generally, in sort of working at the roots of climate change, I've really had to get into a new field. And in doing so, I had to really challenge my confidence. What am I doing as a field geologist in this field of climate? What can I, absolutely contribute to this? And what can I contribute to the debate? And this really meant investing a lot of time. But then also I had to not only invest time to get in the literature, but I had to try to get into that community. So going to talks, starting to put out a few papers. It took about 5 years to get to a point where I could actually start to get funded in climate, actually, and not just in sort of field geology. So it takes risks, and it takes time to develop a subfield, but I think it's worth the time. The third point, being an excellent collaborator. Because my lab is really limited to the field and sample preparation facilities, I really need to work with people with analytical facilities, and I recognize that I'm not an expert. So I see some of the people in the audience are people I collaborate. But I just say, as an early career researcher, I've benefited just hugely from the creative, really talented peers that have been around me. And I've tried to recognize that these relationships are some of the most important relationships I'll have in my career. So taking them seriously, being a great co-author, really spending the time, turning things back around to your co-authors in time, and really learning what you need. These are just critically important in my career, and I think for others. With respect to mentoring and asking for help, I had a mentor who just wanted to challenge me. And that's one form of mentoring, but as Emily said, it takes a community, it takes a lot of different approaches. And so for me, I look at mentoring as more of a lifetime project. I'm still learning. I think there's tons to learn to be a better mentor. And rather than a sort of one-size-fits-all style, I've tried to give each student what they need, and sometimes that was what I received, but other times it's something extremely different. And I need to give them space to fail. And basically, I've still got a lot to learn in this respect, and so I'm trying to improve my mentoring. Last few points in terms of both help and release. I've been really fortunate to be at two really supportive departments, but at times I've had to really ask, this is what I really need. I need a release from teaching because I need to spend time with my kid. Or I need to say no sometimes because when I'm going to say yes, I want to do it with all my heart and really invest in it. So don't be afraid to really say no. And in being able to find that and being able to say no to some things and spend more time with family, I think I've been able to find a healthy work-life balance, and part of that has been moving to California and being able to, when things suck, go run out in the mountains and then come back fresh again. So, thank you.
Our fifth medalist is Erich von Seville, and he'll come up, and then right after, will all 5 speakers come up to the podium and sit at the table.
Thank you. Okay. Yeah, so it says there, oceanographer and climate scientist. But really, I never even thought I would become a scientist. I still remember I went into undergraduate, and on the first day, I had the plan to become the weatherman. It was my dream to be on television, to be the weatherman, and to explain to the rest of the Netherlands what sucking weather we would get that day. And it was really only during, I guess, my master's when I went to sea, and for the first time I experienced an expedition. I went out field work on a ship, 6 weeks, in the middle of the Atlantic Ocean, and it was absolutely fantastic. And it was only at that point that I realized, wow, this is just awesome. This is just great to, first of all, be an oceanographer, somebody who studies the oceans and how they move and how the ocean works in climate. And also to be a scientist, somebody who explores, who dares to ask the big questions, who dares to just go out there and seek the unknown. So I am an oceanographer, and essentially what I do is I ask the question, how do ocean currents move stuff around? And that stuff can be anything. It can be heat, it can be the water itself, the nutrients that feed the ecosystems in the ocean, Plankton, tuna even, the postdoc who did a tuna project. But most of all these days, it's plastic. So most of my funding now comes from microplastic research, wanting to understand whose plastic ends up where. I play the blame game. I create numerical simulations of how ocean currents move that stuff around. And as you see there, this pretty picture, maybe you've oriented yourself a little bit. We're of course looking down in the Arctic here. And all of these lines are individual particles of virtual ocean parcels moving through the Arctic, through the North Pole, in the Pacific, in the Atlantic Ocean, and also showing that really the ocean connects us all. And that is why I'm so excited to do this. So a bit about my career. I'm Dutch originally, and I did my undergraduate and my master in the Netherlands, and then I also stayed for my PhD. So I spent 10 years at the same institute. And that may sound like a long time, but after that, I was really lucky to have a partner who pushed me actually for moving abroad. She really wanted to see something of the world, and I think that as a scientist, if you're lucky enough to have a partner in a family situation that you can move around, then there's no better job to explore something of the world. So we've lived for 2 years in Miami, where I worked at the University of Miami as a postdoc. Then we went to Australia, essentially because my partner said she really wanted to live in Australia. So I found a job there, first as a postdoc and then later as a fellow. And then we went back to Europe. First of all to London, to Imperial College, as a lecturer there. And then Brexit happened, and I kind of did my counter-Brexit essentially. But it was more a pool where I went back home, back to Utrecht, the circle round. So 7 years abroad, and I think that's important. It's important to have that network. And it's especially at conferences like these where I suddenly realized just how many people I'm somehow connected to because I've lived in the US, because I've lived in Australia, because I have a network in the UK, and it really, really helps. So a bit more about, well, what my philosophy to science is. I don't really have 5 key messages like Francis has, although I subscribe to essentially all of them. But I do have these ideas. I mean, if I would say something about what my own drivers in my science are, it's first of all interdisciplinarity. I think that the really exciting questions are on the crossroads between the different disciplines. And that's not only the AGU disciplines, but also much further from there. It's the interactions that I have with the biologists. It's a paper we once did with a bunch of archaeologists about a shipwreck found in New Zealand in the Journal of Archaeology, which is really fantastic. And it's really about these big questions and the exciting. It's hard to do. It's hard to learn each other's language. It takes effort. It takes time. But really starting to work with these other groups is, to myself at least, extremely gratifying. Now, the other thing that is crucial to what I stand for is open science. I think that I am here now because I've always been extremely open in sharing everything, all the code that we provide. We build software in my group, essentially, and that software is radically open. In fact, you could download it on GitHub, burn it on a CD, and start charging $10 for it. And you'd be totally fine. If somebody wants to do this, if somebody wants to actually take what we wrote and can find a business model around it and sell for profit, then who am I to say that that's a bad idea? Given that I've, for my entire life, been funded on taxpayers' money, I don't think that I can actually stop distribution and uptake of whatever we provide. So I'm really for radically open science, open access journals, open and reproducible code. Where I myself draw the line still is open proposals. I do put my funded proposals online, but to be honest, I find it extremely, extremely scary to put my unfunded proposals online. Even though, in fact, I think it is what we should do, right? If I have a good idea and I somehow can't write it up to the point where it actually gets funded, then wouldn't it make sense if somebody else takes up that idea and pushes it further. The things that are unfunded should be out there too. They should be the things that we want to share. And that is the only way to get science further. Because I think one of the problems with science these days is that it's much too personal. It's much too much about persons wanting to be in the game, the competitive nature of it, whereas of course we're all in it together. And if my colleague has a better way of putting my idea to paper and actually getting it funded, then maybe I should support that. But again, I'm not yet doing it. I'm just thinking about it. Public engagement is important. It's this interaction. It, of course, is very closely aligned to open science. We are not doing this for ourselves. We're doing this for the public. And we should always remember that. And then a few things about how I've gone into my science. The first of all is I found a unique niche. I think I am also where I am because I had this niche, this numerical simulations of stuff moving around the ocean that nobody has. And I was extremely opportunistic about that. I was one of the very first to do this for microplastics. And I still remember bumping into my old professor from my PhD. And he told me at that time, and this was like 5 years ago or so, he said, "Why are you wasting your precious brain capacity on something as stupid as plastic in the ocean?" Right? And that is, at that point, it was extremely opportunistic. Nobody was doing plastic. People were laughing at proper scientists doing plastic, but I stayed with it. And now I am here, well-funded to do these kind of things. I've put up my time. Thank you very much.
All right, now I think we're going to invite all of the speakers up to join us here at the table. All right. So I think you've heard some common themes here from the honorees, the Macelwane Medalists from this year. And so now is an opportunity to sort of have a conversation where we can further those themes, maybe draw each other out a bit. I think maybe I'll start by asking a question or two, and then we'll open it up to audience questions, and you guys can ask these guys what's on your mind. So just to get us rolling here, I've written a couple of questions down. And one, I guess, is something that several of you have already touched on in your remarks, but I'm wondering if maybe we could go down the line and people could say something about sort of qualities that you think are particularly important for successful researchers. And just, you know, there's a lot of things that go into this job, and like we've said, there's intellect and communication and experience and empathy and focus and drive. What are some that you feel like in your experience, both personally and with your students or your postdocs or other people in the field that you think are particularly vital to really make a successful researcher? If you want to start with that, Anton.
How it's working? It's working. Great. So, particular property which can help you in research or something like that?
Quality.
Quality, okay, great. Yeah, so I think most important things, and it's what I try to explain to students which I deal with, that you should do more than people expect from you. Otherwise, you will stay in an average line, and it's not good to be averaged. It's better to surprise people. So what it means just means that probably better to work more and more hard than generally people working around you. So this is, I think, important quality to make a good research.
Sure, that's great, thanks.
So I would say your success will largely depend on your team, including students, postdocs, and people you work with. So spending time and effort and building a team that's competent and also developing great relationships between students, and of course you and your students, and also between your team members, will make a huge impact overall in the quality of your work.
And to maybe build on that, really being open to what you don't know and going asking help with collaborators when you need to. And so finding the line between being stubborn and really going after a problem, and then knowing, okay, I actually need an expert here, and I need to go get help. And some of that comes through mentoring, and you can develop that in time. At what point do I really need to go actually get help and get an expert, and at what point do I need to just really, really dig in more? So it's a balance, and it's a skill that I think can be developed with time and through mentoring as well.
I would say that the people that grow the fastest are those who seek feedback and then implement it right away. And so that's something to always think about, both when you're getting feedback and how you can build in those loops so that you have the chance to do that.
I think the best, or one of the important skills that hasn't been touched upon to be a scientist, a good academic or a good scientist, is actually to also have an open mind to another career. To always, and especially at this early stage, to be aware that there are perfectly fine other careers, and to make sure that you always have, well, yeah, even I want to say something to fall back on, but even that sounds negative, because it's not really falling back. It's just keeping your options open and being open about what comes your way, and maybe even being a bit opportunistic about that. And I think that if you do that, then it would reduce a lot of stress, because you can always do whatever you want.
Great, great. So that was a nice little round. I like that you guys all kept it kind of to the point. That's great. So I'll ask one more, and then maybe we'll go to the audience. So obviously you've all done amazingly well in your research careers already, and this award is just one means of assessing that. But I'm wondering, though, if you had it to do over again, are there things that you would do differently? Different discipline, different courses you would have taken, different advisors, mentors, reflect on it. Are there any things that you would change, or have all the lumps been necessary to what you're doing now? Go down the line again.
Okay, so I'm again first. Others have time to think.
Sorry.
No, it's fine. It's fine. Somebody should be. Yeah, okay. It's not so bad. Yeah, generally, I would say that there is nothing I would like to keep except the people which I was working with, because I really was lucky to deal with very good supervisors, very nice colleagues who teach me a lot, and generally I think it's important to orient not on the names, on the hierarchy, but mostly orient on good people to deal with. Generally, good researchers are good people. So I think I can change almost everything in my career except the people I deal with.
Nice.
Well, I have recently started sharing source codes of papers we publish. If I start over, I would do it from day one, from the very first paper. Now it's a little too late to go back and do this for all the papers, but this is something that I encourage everyone to do.
I wouldn't have screwed around so much in college and wasted a lot of time. I would have learned more chemistry. That would have been nice. I would have learned to be a better programmer. That would have been good. I can think of a bunch of poor hiring decisions I've made, some errors I've made in papers that it's like, I wish I would have held on to that paper a little bit longer and thought about it more. So, there's just a series of things that I can think about and I could get mad about. And if I do, I'm feeling cranky about it. I just go run in the mountains and get over it, and then just go back and try to do better and work hard. So, lots of things. You're going to fail, you're going to screw up, and you just keep going for it.
So at a very early stage, I probably should have taken first-year biology, but I basically have no memory, so I was always afraid of having to memorize things. And now I wish I knew how anything alive worked. So anyway, there's some. I wish that I had taken some opportunities that, in retrospect, feel like very small things that would have helped me speak a few more science languages.
I wish that I would have at least worked for a while in industry, because I really have no idea what industry is like, and that really stops me now from interacting more with them. I've been, every single day of my life, I've been in a university environment, and that feels a bit insular. It's a bit late now to change, but earlier on, a few years or outside of a university would have been very healthy, I think.
That's great, yeah. Julio just reminded me that I was a corporate lawyer for a while, so maybe we should talk after.
Yeah.
So, with that, I'd like to make this more of a discussion with the audience, too. So hopefully some of this is inspiring thoughts in you all, and you've got some questions to pose to the panel here. Any takers?
Yes.
My name is Jeff McDonald. I'm a past president of the hydrology section. I've really enjoyed this discussion. There have been some excellent points made and such an impressive panel. My question, I guess, is how has luck played a role in your success? I teach early career mentoring classes, and this comes up time and time again. And I think pondering that is also, bathes you in gratitude, but also helps you kind of connect with those that are maybe a bit farther down the pecking order in terms of your stunning early career success. Just wondering if you could reflect on maybe how luck has played some role in getting you to where you are now.
Eric, you want to start this time? Let's go the other way.
Sure. Well, I sincerely believe that luck has played a major role in where I am now. I can still remember the accidental, even meeting up with my first postdoc advisor at a conference over drinks, and thereby landing my first postdoc at the University of Miami. That was just coincidence. It was haphazard. It was luck. Everything is luck. But on the other hand, I think that there's also many different pathways that you can take. So it's a little bit difficult. I mean, it's not that only this pathway is the right pathway.
So I would be lying if I said I didn't think about it as luck, but the word that I've come to use is tailwind. And so I often think about my sort of white, middle-class U.S. tailwind that I have. And when I think about that, I just try to think about how I leave that door open, how I open the door behind me, and how I realize who may not have that tailwind. So that's the way I think about it.
Yeah, I think Emily brings up a great point, is that we've been pretty blessed to, when we have had mistakes, we've been able to recover from mistakes, and a lot of that is because of a privileged background that's been very fortunate, and also a lot of mentors. And again, there have been these circumstantial events that I think are idiosyncratic and important in everyone's career. But I think the big thing, and I'm seeing this now at a state university, and seeing the differences in backgrounds and the small changes that allow people to succeed and have others have a much more serious consequences when they make mistakes. And so, yeah, not only luck, but being very fortunate in our safety net.
I agree with everyone. It did play a role in my career. Some of the people I met, including my postdoc mentor, was basically random chance somehow, at least the first time around, and then things changed, of course. Same with my PhD advisor. The way I met and started work, it was basically one person introducing me to someone else, and then that was it basically. So yeah, it's a combination of things, including luck and.
Yep. Okay, so there is some advantage to be first, because otherwise all good answers are ended to the moment when we start speaking. Okay, so I personally believe it's better to not think about the researcher as a consequences of luck, and I think that luck can determine the time scales of particular things happening in career, but something can be slower, something can take more time if you are not lucky, something can be happening much quicker if you're a little bit more lucky, but generally it's better to not rely on this at all and think that more or less everything what has been happening with you is more or less determined by yourself.
I wanted to add something to this conversation, and that is, my son always reminds me of something that I told him when he was a little kid, and that is that you have to learn how to navigate opportunity. And while that does, in fact, involve some luck for opportunity to present itself, you're also preparing for those opportunities to come up. So actually, one of last year's medal winners, Stephen, made a comment that really rang true with a lot of people, and that is that as scientists, we walk around with 10 or 12 big ideas for a long time. And usually, opportunity is going to knock for one of those. So there's some other questions. Yes, in the back as well.
Do you want to get that?
So I think I'd like just quickly to repeat the question. So your question is, after you have some mentoring type meeting and you've got some ideas, how do you maintain the momentum of that as you go forward? Is that right? Yeah. Okay. Yeah. Maybe I don't know.
Okay.
We'll start down here. We'll flop back and forth.
Yeah, good question. In sense, good because I never think about it before you ask me. I think it's mostly it's so personally determined. Personally depending on the different type of students and different personalities. So I don't think there is any particular rule that can be used. You always should decide on the situation, depending on the particular person you deal with.
I think people need incentive to get involved in, research collaboration, right? And you need to think about that very deeply, and basically be convincing that this collaboration will eventually lead to something fruitful. It's not easy, depending on what you plan to do, it may be different, but I think you need to think about that incentive for bringing people to the table.
I'll give you a short example of my own group. Is that I've had several female students, and I don't think that I am necessarily the best mentor in all the things that it takes to be successful if you have a different background than I do. And so I've tried to, for some of my female students, I have pointed them to a couple of my colleagues who have been very successful women in science, and I've put them together and I've tried to say, hey, why don't you talk with my friend and colleague about some of the issues that you're seeing, and maybe they can give you another opinion from what I'm telling you. And so just recognizing your own limitations and your failures and your lack of experiences as some of your students, I think at least I try to build a network in that way and trying to recognize what a student may need that I can't give them.
I would say that at the same time as I'm building collaborations, I'm also dropping the ball on a lot of things. And so both things are happening at the same time. One thing that I like to do is be a hub. And so if you are a hub and you like connecting other people, then you sort of naturally stay connected. So you don't necessarily have to be involved in that connection, right? You just see that person and you connect them to their next place. And by enjoying that space, you end up sort of being aware and sort of tangentially involved in a lot of things, and then can be deeply involved in a few of them. So that's one way to do it.
Yeah. So I agree with a lot of what has been said, and especially what you just said, Emily. I guess the whole thing is to not only be a good collaborator, as has been said before, but even to be a good citizen, in the sense of a good scientific citizen, and be kind to everybody around you, and hopefully that kindness will shine a little bit back.
So let's take is there a question from a younger person? Is that Wenchan?
just to repeat, have you guys on the panel experienced some downtimes or periods that you've struggled maybe that you'd like to share with the group?
I'm first.
Sorry. On the spot. Sorry.
Yeah, no, I struggle to think about that. I mean, my biggest downtime was, I guess, when we were in Antarctica and we got stuck on a ship, and it was a bit of a emergency situation, and we had to be rescued, and there was really big pressure, especially on my family at the time, because I was down there in Antarctica. They didn't really know what happened, and since then I've never been back to sea. So my family doesn't want me to go back to sea anymore. So that's something that, because of that one single event, it's really changed my career, not for the better.
I have sort of this inner-outer monologue of self-doubt that goes on all the time. And so, yes, all the time. Every day I'm like, when are they going to fire me? Like, when are they going to figure out that I shouldn't be here? Like, that is happening all the time. I would say in a recent aircraft mission that I led last summer, or 2 summers ago now, sort of that self-doubt crept out in a lot of ways to the pilots. I was like, don't crash the plane. Should we be doing this? I don't know if we should be doing this. Is it the right decision? And they were like, you're a nervous mom. And I was like, yes, I am. And I was like, but I'm great at logistics. And they were like, we recognize that. So anyway, I think that some humility and being able to laugh at yourself in those situations will help. At least that's what helps me, is just sort of voicing some of my nervousness and having other people be like, you're ridiculous. Move on and just do your job. Has sort of helped me.
So to maybe reassure Emily that she's not on her own, there's actually a name for this. It's called the imposter syndrome, and I feel it constantly, and in fact feel it up here. Like, I don't deserve to be here. Or, anytime I'm working on something new, oh man, they're gonna find out I don't really understand this very well, and I must be tricking people because I shouldn't be doing this. And in a way, it's this internal monologue that it's both a curse. I think it's incredibly common, or at least I hope so. That's why it's nice hearing it from Emily. It's like, oh, it's good. That's the way I feel. But the other aspect of it is you can start to try to use it to your advantage. So, being really nervous that, oh, I know less about this than everyone I'm working with. I'm the village idiot here, in this project. It forces you to really be reading and trying to catch up and trying to work harder to catch up. And so I think if you're just aware about your insecurities and try to leverage it to really catch up and do better, that it can be helpful. And just also know that I think other people also feel very insecure and very down and dark a lot of times.
I agree with everyone. We get more proposals rejected than funded. At least that's the case for me. Same with papers and so forth. So it happens all the time. And I think we have to develop a thick skin for this job. And I guess learn how to navigate that and not let that overwhelm you.
Okay. So I'm mostly working with theory, so it's a nice story that nothing dramatic can happen with you when you're writing equations. The bad things that you cannot say, cannot find any interesting story in your experience, like really experimentalists can do. And about how to survive that, when you fail, I think you should take everything more or less with humor and irony. There is nothing really important and so important and serious that you should be significantly disappointed by this, because life and science is a part of the life, so there are a lot of failures. It's fine.
Other questions? Jim, I'm going to have the young lady behind you. I will get to you next.
So yeah, just to try to restate the question, those of us that are working in interdisciplinary areas, to what extent, I guess, do you need a team of different folks to help really ensure that your message gets across and you're doing good science that's publicly relevant? Or? Okay, yeah. I don't know if anyone wants to take that on. We don't have to have everyone if you don't feel like that's your domain, but.
Go ahead.
You know, so my team is, or my work at least, is inherently interdisciplinary. And as I said, I work with biologists, with archaeologists, with geneticists, with mathematicians, with whoever. And I think it's not so. It's partly about the skills that you say to actually pursue the project. But I think it even starts before that. You can't actually pose the correct question if you don't have the right people in the same room, and if you don't first talk to each other and understand what is the thing that you want to find out. It's a bit this second way of working in your book, where you explore the woods, and you're just it's much more fun to do that exploration together in a team, and that is, to me, what interdisciplinary science is about.
I would say two things. So one, when you're putting together a team, it's good to make sure there's people who think differently than you. And I work on teams where these people exist. And let me give you an example. So I am like big thinker, not really worried about the details. This is super exciting. My research scientist in my group is the exact opposite. She's like, what electrical outlet will we plug that into in 4 years? And so the two of us together are very good because we respect each other, we are not intimidated by each other, and we realize that together we will have both the reason we are doing it and the correct toolkit. Both will come together. And so I think that thinking about, you want to think about people who make you a little bit uncomfortable and sort of also point out the things that you're forgetting. On another team, there's a woman who she thinks through everything as well, and I just want to get it done. And so I'm always like, come on, can we just move along? But in aggregate over time, our work is so much better, and we really appreciate each other because I will push it forward and she will always hold the reins so that we don't move too quickly on something. So I'll be annoyed with her and she's always annoyed with me, but we're very great friends because of this, so.
And just to add something to those thoughts, I think you're right about these big projects taking a lot of different skills and different backgrounds. Strangely, as you get further along in science, you end up in these managerial roles that you're not trained for whatsoever. And instead, we're training people to do science, and then they get further along, and then we have these big projects, big groups, and you're supposed to manage and organize. And so this is a piece that I feel like I am still learning a lot about, and think it's maybe a hole in efficiency. I mean, what we spend a lot of our time on is writing, communicating, organizing people. None of this we're trained in as scientists. So just being cognizant of that and knowing that, okay, where do I need to get help here, and where am I really ill-equipped here is potentially useful.
I wish I had someone to market my research. Yes, marketing is important, but we're not really trained in at least that part. Hopefully you are in an environment where your university helps a little bit with that. And then the rest of it is you and your team building the relationship, as my colleagues mentioned here, to get what you want to do done efficiently.
Yeah. Okay. From my experience, when you start any type of project, one of the most important problem in the beginning is just to find right questions to address during the project. And one of the way to do it is just try to collect the people who have absolutely different opinions on the same point. More conflicts in the beginning generally, from my experience, generally ends with better results in the end. So I try to, mostly communicate not with someone who agree with me with everything, but who disagree with me in most of the points which I try to bring.
I wanted to add that, and that I worked for a federal agency, the U.S. Geological Survey, for over 35 years. And I think one of the things that some people did really well and others didn't do it very well, even kind of at the top of the management hierarchy in USGS, is actually realize that it takes a village to raise a discovery, and that that village is made up of a lot of people. And so you kind of need to learn, you need to make a habit of recognizing people who made real contributions and made things happen. And that might actually be the contracting officer, for example, that allowed the contract to go through, that allowed you to build a toxics program in a federal agency. And so this is really, really important to engage people that might seem tangential to what you're doing in terms of the science, but engaging them in the science and then recognizing and celebrating their contributions. Jim.
I've got a comment and a question for you. The comment is you shared a staggering amount of wisdom here this morning. And for me personally, one of the pieces of advice that you gave that really resonated was the advice of don't be afraid to say no. So I'm a retired scientist, and I think one of the biggest challenges of science is how you allocate your time. It's the most precious resource. So I think it's terrific advice. You're going to face times in your career you've already done this, well, where you have to say no. My question is a question from the perspective of a journal editor. So the biggest challenge of journal editors is finding peer reviews. And I'd like to hear from you what your experiences are of being drawn into the peer review process. I'd really like to know how that being drawn into the process evolved from the time you were a student to the point where you are in your careers now. And I really want to know is, what I'd really like to know is, are we fully exploiting your generation doing peer reviews? And if we're not, how can we change?
So yeah, to restate the question for the online audience, it's about what's the trajectory of your role as a peer reviewer going back to when you were a student until now, and are you feeling like you're being fully utilized, and if not, how can we improve that? So I don't know, which end are we starting on?
Last time it was this side, so
Okay.
I think it's my turn. Yeah, it's interesting story. I was lucky to have a very nice guys supervise me, so I try to follow their rules in this way. And generally, I try to don't consider students as somebody who should be educated, but mostly like a colleagues. In that case, they much more appreciate the discussion. So I don't try to say that, of course, different levels of research requires different experience, and somebody know more than, somebody who already in the field know more than somebody who just come to the field, but the general opportunity to do something important are almost equal. So no need to be to look on the no need to try to build any hierarchy in the relationships. Better to try to deal with everybody like you would like they will deal with you, something like that.
I'm editor of Earth's Future, and it's becoming really harder and harder to secure reviewers for papers. I think there are more and more submissions, and people are very busy. And I rely now mainly on early career and mid-career scientists. I noticed that more senior people don't accept review tasks, and fortunately, still early career and mid-career people contribute to the peer review process. In my case, I've done a lot of reviews in the past, and I have learned a great deal from the process. But again, I see it's becoming really, really hard to secure good reviews. And I notice people are spending less time on reviewing papers. Even the review comments you get sometimes are not really deep, which is the trend, apparently. Then probably there is not much we can do about it. But I hope at least early career scientists spend time and effort in the peer review process, because it's a professional development. It also helps them in their own paper writing. It was the case for me, at least.
So there's more journals, and there's been a corporatization of academia, so there's more publications. So it's difficult to keep up with that. And when I was more junior, I'd be asked, once in a while to review, and it was very good experience. And as a junior person, I would recommend building up that experience as a reviewer. As you get more senior, you can't say yes to all of them, or you will spend all of your time doing reviews. And at a certain point, it becomes a thankless task. It's very important for our community, but you have other responsibilities. So at a point, you have to say no. And it's gotten to the point, for me at least, I say yes to journals that I am actively submitting papers to. And that is part of the, quid pro quo, that you develop relationships with editors, with reviewers, and also, if you're expecting to publish in a paper, it's part of your, in a journal, it's part of your duty to review in that journal. But I have to say no to, particularly to journals that I'm not actively submitting papers to.
Yeah, I think that recently I feel like I get asked to review every paper with the word peroxyacetyl nitrate in it. And so some of those papers are I can immediately see are good, and I can, based on the abstract, and some I can see are immediately of lower quality. And so I try to take some of them, but not all of them. I think that it would be good to make it clear that, or I think it would be good if we could do reviews as teams. So it would be great often what I try to do is say, can you pass this to my student? And then I'll work with them on it. So they'll read it, we'll discuss it, but they're responsible for the write-up. So that means that I can put some effort into it, but not carry it all the way. And so I think that graduate students benefit enormously from going through this, especially as they're learning to write their first papers. And so there's lots of things you could do. I mean, you could have sessions at these meetings about how to be a good reviewer, right? And try to ask people to put their names on lists for AGU journals, graduate students in particular, because I think they really benefit from it and are not asked. And it's sometimes I'll even say no I click no before I realize, oh, I should make Jacob do that, right? So I think maybe do a little more proactive on the journal's end would really help this process.
As an editor, I really appreciate that strategy.
Well,
I imagine you feel the same way as
yeah, so I was going to say exactly the same. The first paper I reviewed was actually as a graduate student, where my supervisor said, here's a paper on your topic, now together we're going to review this. And it's been a fantastic experience. I think I put in 4 times as much time as he did, obviously. The review process was better for it. I now do the same with my students. I give them 1 or maybe 2 papers during their entire during their entire PhD to get the experience. The other thing is that I'm trying to go for 2 papers 2 reviews for every paper that I submit, with the idea that is kind of what needs to the system to keep on. So if I'm a co-author on a paper, then I will take 2 papers to review to keep the system turning. But what I'm doing lately is that I'm only accepting reviewer invitations from gold open access journals. So if it's not gold open access, I'm just refusing. It's as simple as that.
But the editors have to be proactive if they're going to involve students, because there is supposed to be a confidentiality with the reviews. Yeah. So that needs to be stated. I have not done that, in part because we're not supposed to.
Yeah, and I'm not sure if I'm supposed to, but usually I email them back and say, this is what I'm thinking of doing.
Yeah, so it'd be great if the editors suggested that.
The other thing I think is that if we're going to have sort of blind reviewers, I think we should have blind authors. So I think there's no reason why we have to have the process only blind in one way, where you don't know who your reviewers are. It would be great to also not know who the authors of papers are. And I think that could have a lot of benefits for the review process.
And for students' involvement.
And for students' involvement.
There's an intrinsic hierarchy when students know, ooh, I probably shouldn't say this because it might be bad for my career. So the double blinding would be great.
I did want to make one observation relative to this question, and that is that after reading about 220-something nominations over the last 5 years for Macelwane medals, one of the hallmarks is actually recognition for excellence in refereeing. I saw it in most of the packages, sometimes 2 or 3 citations for excellence in refereeing. And what that told me is that these are really serious scientists that can not only write a critical review, but can write a constructive one. And so usually the people recognizing them are, in fact, the editors. And so I think this is really important because I read a lot of packages for other things, and this was not a hallmark of the other packages. This was a hallmark for the Macelwane Medalist. Are there other questions? Yes.
Yeah, so the challenge of doing interdisciplinary work that has been recognized by many of you is important, but knowing that universities tend to hire in specific disciplines, and how do we manage that?
Okay. So generally, my understanding and my approach in this thing that, I mean, interdisciplinary work doesn't mean that you, instead of one paper or one study in your particular research, you do the study in something between 2 researchers. It's looking like more you do both study in your research and study in something nearby. So something like it requires a twice of efforts, but finally it doesn't reduce your recognition in your particular field. So it should not result in decrease of activity, but mostly like increase of activity. So you still should be able to sell it to professional community, because it's looking very unprofessional when people try to speak about their research in an area where they are not experts at all. And it's better to stay, I mean, to describe what you are doing in front of experts who can understand what you are doing. So in that sense, interdisciplinary doesn't, at least for me, it doesn't mean that you stop doing what the university expects from you. It just means that you do something additional to this.
That's a good point. And not only most people are hired in disciplinary departments, at least in the US for tenure evaluation, you need to show depth in a certain topic and also independence. And independence means you work with your own students without help from others, right? And you need to demonstrate. At least in many universities, that's the culture. So I think that's a conversation you need to have with your department chair and dean about how they value interdisciplinary versus like, I think you should have both, like a combination of in-depth work in a certain topic and also interdisciplinary research. I don't think it kind of makes sense to say that all my work is interdisciplinary, right? At least you start from somewhere, you develop depth in a certain area, and then slowly you branch out. And if there is a balance, I think there should be absolutely no problem.
I would just say it's more difficult to do as a student or a postdoc, and maybe it's bad advice as a student and postdoc, and for me at least, it's really taken a lot of time that would have been spent otherwise, maybe writing papers in something closer to my field to develop enough of a feeling for another field to be able to ask good questions and work with people. So it's been a lot easier as a faculty member once I've already been hired to be able to start doing interdisciplinary work. So it depends on your career stage, I think. It's not necessarily great advice for someone who hasn't been hired yet to start doing interdisciplinary advice. So I would say it depends.
Yeah, I do all of that work as part of a team, and on that team I bring something very specific to the table. And so I'm pretty clear that that's what I bring to the table, and I don't try to do the other pieces of it. And so sometimes that's bringing a network so that social scientists can use that network for their data collection, and sometimes it's making maps that an epidemiologist might not be able to make easily on their own with satellite data, right? So I think of it as I bring this to a team to enable different types of questions to be asked, more so than that I have all these skills. And so I still brand myself as an atmospheric scientist. Hopefully that helps.
Would you say, could I ask you a question? Would you say that it has been a difficult thing for time, and that in these big projects you have to spend a lot of time learning so you can be a good collaborator to these other fields?
Yeah, I have to spend a lot of time learning, but sometimes I also just have to trust that the other people know their game. And so when you think about your team, you want to make sure that you have either 100% confidence in the rest of the team or you're out. That's the way I sort of treat it.
Yeah, and then the final thing to add, I guess, is that I think academia is changing. At least in Europe, where I'm based now, we're more and more going towards interdisciplinarity as a norm. And what you're painting the picture of very disciplinary institutes, that is going away, at least. So I'm hopeful that in a few years that this question wouldn't even come up anymore.
Yeah, I'd actually like to add to that before I make a few concluding remarks, that I agree completely with what Erich said there at the end. Increasingly, we're seeing that departments and institutes are forming that are inherently interdisciplinary. And I would also add to something that the panelists said here, that there are individuals who, in their own research groups, are using tools from multiple disciplines. So it's not all about team science, although that is important to a lot of the work here. So don't be totally discouraged depending on your area, and we could talk more. Okay, so hopefully you guys have had as much fun as I have listening to these medalists, and it's been an honor for Julio and I to convene this session. I think we heard a lot of wise statements and really interesting perspectives from, in a common way, really, from a very diverse group here, and that's telling, I think. Echoing something that I emphasized at the breakfast, I really think that drive or intrinsic motivation is a really important determinant of success as a researcher. A lot of these other factors that people talked about are also really critical, the luck and the focus and empathy. But no one can really push others to achieve, at least not for long. You really have to want it for yourself. And that intrinsic motivation can come from different places in different people. In some cases, some of you out there just want to discover something fundamental about the world. You want to feel the tingling in your fingertips that you understand something about nature. Others of us really want to try to change the world and make the decisions that are getting made be made in a better way. There's some people that, ego enters into this. They want to get the recognition, be famous. All of those are sources of this internal motivation, but regardless of the sort of species or flavor of it, it has to be there because you're going to need that to help you through the low points and the struggles that you heard about. I also think it's important to emphasize something that a lot of the panelists raised, which is you need a certain ruthless efficiency, the ability to say no, which was emphasized. We are by now all beset by competing interests, no matter our career stage and demands. Some of those might be personal, some might be professional. We're having to balance this work-life load. And one needs to have the ability to manage those demands strategically, learning to prioritize the things that are important to accomplishing their goals, and meanwhile letting go of others. So really, this is getting to what Julio mentioned about navigating opportunity. We have to be ready with important ideas in mind so that every experience can be interpreted and used to its best advantage. In any event, these researchers are a testament to what this kind of dedication and been well applied can yield. And so I'd like to just conclude, and please give us a round of applause and help me congratulate them again. Thanks.